Alright guys, what we're looking at today is quadratic regression using our Inspire calculator. So number one says find the regression equation that best models the data from the following table. So here's our table. Alright, so now what we're going to do is we're going to open up our Inspire and we're going to insert this table using these steps right here. So we're going to open up a new document. We'll go to Add List in Spreadsheets. We'll insert column names, insert the data, and I'll go from there. So let's open up our calculator. So we're going to go and add a new document. So let's go new document. What we're going to do first is we're going to add list in spreadsheet, which is number 4. We're going to label our columns X and our columns Y. Now notice that I'm labeling up here in the A and the B column. We always skip this equals to. And we're going to insert our table. So our table has values of 3, 1, 5, 9, and 0. Our Y values are 21, 20, 18, 7, and 19. Now, it's important to not have a point highlighted, so I'm going to go ahead and arrow over to this C column. Once I have inserted my data, I'm going to open up a new page. So let's go to Control, Doc. I can't get Control. Get out of the way. Control, Doc, and open up a new page. Alright, now once I have my list in spreadsheet entered, now I want to add data and statistics. So let's go to number 5. Now here's my points. I need to tell the calculator where the x-axis is and where the y-axis is. So we're going to go ahead and label those axes. You can see that I have a quadratic function here. It's a parabola. So we want to find the quadratic regression equation for this. Alright, so what I'm going to do is I'm going to go to Menu to find the line. I'm going to go to Menu. I'm going to analyze that graph. Well, it's regression, which is number 6. And we're going to show quadratic because this is a quadratic regression. So there is your function right there. So I've got f of x or y, f of x equals negative 0.305 x squared plus 1.4x plus 19-ish. Okay, so I'm going to round that. So here's what I got, right? F of x equals negative 3.035 x squared plus 1.4x plus 19. So it's in standard form. What's a, what's b, what's c? Well, a is the coefficient in front of x squared, so in this case it's negative 0.305. B is 1.4, and c is 19. Now, I rounded these, obviously. Okay, so it's going to be a little bit different than what you got, maybe. All right, let's go to number 2. Same thing. Number 2, I have a table here. I have the years and I have the population. Well, obviously, years are my x values. Population is my p values or my y values. It says the table below shows the population of a town from 1996 to 2004. So 1996 would be year 0. 2004 would be year 8. Assume that t is the number of years since 1996 and p is measured in thousands of people. What is the best fitting quadratic regression equation? So again, I want to find the regression equation here. So I have my table. I'm going to insert that table just like I did for the last problem. So once again, let's go to our calculator. We're going to open up a new document. And we're going to insert a list in spreadsheet. The list is basically my table. So we're going to label our columns X and Y. Again, leave the equals to blank, and let's insert 0, 1, 2, 3, 4, 5, 6, 7, and 8. Now the Y values for those respective things are 22.8, 25.0, 26.5, 27.1, 27.8, 28.1, 27.9, 26.9, and 26.1. Now again, do not have a point highlighted, so we're going to arrow over to my C column. Once I have my table inserted, I'm going to add a new page, Control Document. We're going to add data and statistics to get my graph. Now let's label our axes. So that is my x-axis, that's my y-axis. And again, you can see I have a parabola here, so I know it's a quadratic regression. So we're going to go to Menu to find my line. Go to Menu, Analyze, Regression. And it's quadratic, number 4. So my line of best fit is going to be f of x, or my quadratic regression of best fit, negative 0.213x squared plus 2.08x plus 22.96. All right, so that's what I got for my equation. Now, number 2, or part B, says, use the model to predict the population in 2007. Okay, well, I want to know from 1996 to 2004. Well, this is going to be 2004. So then I have year 9 would be 2005. Year 10 would be 2006. Year 11 would be 2007. So I want to know, when the x value is 11, what is the y value? What's the population? So when the x value is 11, what's the y value? Well, all I'm going to do is plug in 11 for x. So I've got f of 11, or the y value, is equal to negative 0.213 11 squared plus 2.08 times 11 plus 22.96. All right, so again, let's open up our calculator, and we're going to put this into our calculator. So let's calculate. All right, now I've got 11 squared, so 11 times 11, 121. I'm going to multiply that by negative 0.213. So I get negative 25.773 plus, and now I've got 2.08 times 11. And that's going to give me 22.88 and plus 22.96. So this is what I just did. I took 11, squared it, multiplied it by that, I got that. I got 2.08 times 11, I got that, 22.96. So now we can combine these, and then we're going to subtract this piece. All right, so this is positive 22.8 plus 22.96. So I get 45.84, and I have a negative 25.773. So I'm going to subtract that from that. So negative 25.773. So the population would be about 20,000. Right? About 20,000. I'm going to round that. All right, so that's what I did. I got this to get that, that to get that. That's still 22.96. I added these together to get 45.84. I subtracted this piece from it, and I got about 20,000 people. Because again, this is population in thousands of people. All right, so real quick, I'm going to do the table for number 3. Never mind, I don't have time for the number 3.